Hello all, today we are solving LeetCode problem number 1895, largest magic square. So we are given a m cross n integer grid, right? And you are asked to find a magic square. So what is a magic square? So a magic square is a k cross k grid, which means we are forming a square from the grid given, and the row sum of the grid should be equal to a, such that the column sum of the the column sum, each column sum also should result in a, and each row sum also should result in a for the particular square, and the main diagonal sum also should result in a, and the remaining diagonal, that is the other diagonal, uh, the resultant sum of that also should end up in a, which means all the sum of the row sum of the values and column sum of the values and main sum of the diagonals and other diagonals sum should result in same number. So in such case we call that particular square as the magic square, right? And to note this point, all 1 cross 1 square is a magic square, right? Because it has the same value for diagonal and same the only one value for row, and because of that it is a magic square, right? So in this problem we have to return the size of the largest magic square, whichever could be formed out of the m cross n grid. So how do we solve this? How? So for solving this, first thing you have to find is how to form a square out of this grid, from this grid. Yeah, right? So for forming a square, you consider, let us consider this first example only. You consider this as the starting position, and you form this 1 cross 1 square, right? And this will be the starting position, and you can make a 2 cross 2 square here, right? And with this as the starting position, you can make a 3 cross 3 square as well, right? And again you can go for 4 cross 4 also, right? So by 4 the n size is no, it's not m, this is m is 4 here and n is 5 here. So we already reached the limit of the row, so because of that we stop here. Because of that we cannot form 5 cross 5, this is impossible, because we need a square. Since the row is limited to only 4, we cannot go extend further, right? So at this position we stop this, right? So for in the next iteration we consider this point as the starting point, and we form this as the square, and then this as the 2 cross 2 square, and this one will be the 3 cross 3, and this whole thing will be the 4 cross 4 square formed, right? So similarly we jump to this position and we form the all the squares, and this one, and we iterate through all the position, that is grid of uh, ij, and starting that as the position we form the squares, all the squares possible, right? So this is how we form the square. And as I said, there is a limit, right? So the limit is we have to note this observation because this is very important. So the limit will be minimum of m and n, because here m is equal to 5, sorry, m is equal to 4, m is equal to 4 and n is equal to 5. So minimum among this is 4, so that is the reason the maximum size could be formed, maximum size of a square whichever could be formed is 4, right? So this will be one consideration, and to iterate throughout the array, throughout the grid, you will have two for loops, right? And you need one for loop for keeping up the limit, right? To form the square, one for loop to form square, right? So in total you have three for loops. Where can I note this up? Yeah, so I will note for loops here. So totally you have one to find k squares and a row column for iteration, right? This is just for observation to proceed with the coding section, right? And next thing, after finding or after forming a square from the grid, now the task is to check if the square is magic square or not. So if yes, in that case you have to return the size of the square, not the size, the side of the square. So to check if the square is magic, you need to check the row sum, column sum, and main diagonal sum and other diagonal sum, right? So to check this row sum and column sum, again you have to traverse matrix, right? Matrix or grid, whatever you have to traverse, which will lead in a odd big O of n square, right? So to be noted here, we are already consuming three loops, so because of that this will be big O of n cube, right? And combining these two, this will become big O of n power 5, which will result in time limit exceeded issue. So to reduce that, we will be following a prefix sum here to calculate the row sum and column sum to process this, right? So how do we perform the prefix sum? Let me explain this with the first example only, and before that let me clear this things. Yeah, perfect. So if you consider, I will be just running through the example of only row, and then we can jump into the, based on the observation we can jump into the coding part, right? So for the rows, if you see here, the prefix sum of this will be 7, and 7 plus 1 will be 8, and 8 plus 4 will be 12, and 17 and 23, 2, 7, 8, 14, 18, 1, 6, 10, 13, 15, 1, 3, 10, 13, 17. So this will be the prefix sum. So now our task is to find these three sum, right? So as per the question, this is the magic square is formed, right? So first of all we are checking for this particular row, which is row 1. We are having processing by zero based indexing, right? So row 1, we are calculating the prefix sum from this, starting this as the point and this is the ending point, right? So in this case we have to find this particular place prefix value, right, subtracted by this value, which will result in 12. So you can see 5 plus 1 is 6 and 6 plus 6 is 12. So the whole sum of this particular area will be 12, right? And again now you can see here 13 minus 1 will be, again this will be 12 for this row, right? And again 13 minus 1 will be 12 again. So these three rows have 12 as the sum. So yeah, so this is how we calculate the prefix sum, right? And for diagonal, you can see here again 6 4 2, this will be 12. So you will be calculating the sum of this diagonal by processing by the index only, right? So the main, I'll start with the main diagonal. So this is the main diagonal, so this will be the starting point, and because of the starting point, this will be we can call it as grid of, it's not a grid, basically, yeah, it should be a grid, right? Because we are processing by traversing. So you have a row value and column value by as the traversing index. So because of that, this point will be grid of row and column, right? And then this will be this should be incremented by I, which will be the value which we are using to iterate through the value, right? So because of that, you can, this will be, for example, this will be 0 0, this will be 1 1, and this will be 2 2, right? So because of that, in generic we can write this as, I think this is not visible. In generic we can write this as grid of r plus I and c plus I respectively, right? And if you note down the opposite diagonal, which is this particular diagonal, you can say that this is, the row will be same, right? The row will be same, and the way the row getting incremented, this will be the row r, and this will be row r plus I, and this will be row r plus I plus 1, right? So let me write it down here. So first row will be r, and next row will be r plus I, and the third row will be r plus I plus 1, right? So because of that, this will be grid of r plus I, and when you see the column, this is decrementing, right? So this starts from r to, this will be k, because we are ranging from k only up to k size we are finding the value, right? So this will be uh, r plus k minus 1, right? And plus I. So because of that, we can represent that it's not r, this should be c, I'm sorry, c, right? So this will be the index for it, for calculating sum of the opposite grid, right? So totally we have observations for calculating the prefix sum of row and column, right? And then sum to we have the indexing idea for calculating the sum of uh, diagonal, right? So for the positive diagonal, we have grid of r plus I and c plus I, and the other we have grid of r plus I, and this will be ranging from k, right? So because of that, k minus 1 we are considering, right? So c plus k minus 1 plus I, right? So with this observation, let us go ahead and code this sum, right? So we have discussed this totally, because since we are you processing prefix sum, the we need not use traverse the matrix again to calculate the sum, So because of that, the time complexity will get reduced from big O of n power 5 to big O of n power 4. So TC becomes big O of n power 4, right? And space complexity becomes big O of n square actually. And we are using many n square because we are using prefix matrix for the sum, calculating the sum of the row as well as column, right? So first m and n is equal to length of grid and length of grid of 0 respectively, right? And now calculate prefix sum. So since we need a matrix to store the prefix sum, so we name the matrix as row is equal to, this should be 0 multiplied by n plus 1 of size, right? For uh, for anything, this need not be to be worried. In range of, this should be n, and column is equal to 0 cross m plus 1 for m. Row should be m and column should be, this should be n and this should be m, right? Yeah. So now we have to iterate and we have to calculate the prefix sum, right? So for I in range of m and for j in range n, right? So now row of ij, right? So this is equal to row of I and j plus grid of I and j. So we are adding with the this should be j plus 1 because we know the value of row of ij already, right? So because of that, this should be j plus 1 because we will be updating in the next index, right? So for example, this is row 1 or row I, and the next column we have to update. So this is row ij and row I j plus 1. So here is where we have to update, right? So again, now for the case of column, here we have j same, and the I will be changed because of column, right? In the column we have to change the column, right? So because of that, this will change, and this will be column of j I plus grid of ij. Right, now we have to iterate and find loop for square, right? So in this one, if you are not able to form a bigger square, if you are not able to form a bigger square, we would definitely the square whichever is formed will be greater than 1. If not, we have to return 1 because that is the base case. What you are, yeah, return 1, because if no squares could be formed, this just a one square, 1 cross 1 grid will be a magic square, can be a magic square also, right? So for we have to start from k different k shape squares. So for k in range, this should be minimum of m comma n, and we are iterating till 1, and yeah, so backward iteration. So for now we have to traverse through the loop. So for r in range, this should be m minus k plus 1, and for c in range, this should be n minus k plus 1. Because why are we doing this? Because we are allowed to in a first iteration, or in a first iteration we are allowed to create a square. So because of that, if the k value is 1, we are allowed to create a square of size 1 cross 1, and if the k value is 4, but anyway we are starting from the backwards, right? So because of that, if the square value is m, we will be creating a square of size m. So this is how we process here. So now we have to find the target sum, right? So for finding the target sum, we can use this row prefix sum. Using that, we know that for finding target, that will be this particular point. We can consider this particular point and this particular point. So at this point, this will be the row of r comma rc, and this will be row of r c plus k, because this is up to k range, right? So this is the starting point, and this will be c plus k. So because of that, we can subtract the value of row of r and c plus k minus row of rc, right? So target is equal to row of r c plus k minus row of r c, right? So the same thing only we will be using to for calculating the prefix sum of row, right? And we are having a flag is equal to true, right? So now check row. So for I in range, this should be r plus k till k. We can range this, and if now we can paste this, this will be I, and c plus k is fine, and this will be again I, and this should be equal to target. And if it is not equal to target, we update the flag and we break this, and we continue this loop so that we jump into the next iteration. We use continue function to jump into the next iteration. So if it is not equal to target, right, now you have to update the flag to false, right? And then break from the loop. So I mean from the condition, and now sorry, it breaks from the loop, and now if not flag, then continue, right? So this will be similar for column case, just that we have to change some variable, right? So column, and this will be c and c plus k, and then this will be r plus k, and this will be same I. We can have it as I, or for naming purpose this can be j, and this can be j, and row of j, and this will be r, right? Yes. And now here, now we have to check for diagonals. So main diagonal, so diagonal 1 is equal to, now we are calculating the sum. So sum and of sum by grid, so grid of, I have already explained there, this should be r plus I, and this will be c plus I, right? So c plus I for some of these, for I in range, this should be till k, right? Yeah, so till k. And now you have to check the diagonal if it is not equal to target. So if uh, again you have to continue, meaning you will go to the next loop, right? So again you can copy the same thing, right? So now you have to change the values because oh, this is diag and name it as 2 other, and this will be r plus 1 per, oh this is I, my bad, this should be I, and this should be plus I, but this should be c plus k minus 1, right? So c plus k minus 1 plus I, so that is for I range in k. Yes, and you continue, and now if all these are true, then just go ahead and return k, because that is, if this is everything is true, you can say that in the k value only we could able to find the square, right? So k. And one thing to note here, why are we starting the k value from backwards? Because we are finding the maximum, so there could be chance if we start from the maximum value before getting into the minimum one, that is before coming into k value as 1 or 2, we could end up in a result of getting a maximum size, right? So because of that, and for the first maximum value of k, if we are reaching the magic square, we can go ahead and return that. So because of that we are doing this, so let us go ahead and run it. So here in the problem there is few typo, so I mistyped a bracket here, so you have to remove this, and then here I have already changed this in the video I have mentioned this as row, so this should be changed to column because we are traversing in the column. And again this should not be plus 1, this should be minus, or sorry, plus I, this should be minus I. So now after this change, let us go ahead and submit this. And this is an efficient solution. Thank you.